Yeah, so I changed my talk title a few nights ago and opened a pull request to change it. Then I realized they already printed all the material. So sorry if you came here for the lasagna. I thought it was going to be a great pun about how all code is pasta, but you don't want it to be spaghetti. It didn't really work very well with my coworkers, so I decided to change it. What I really want to talk about today is software design. I think it's something that is really challenging in our industry, and I don't think we really do it very well. When I talk about software design, it could mean a lot of things, but to me it means not the file organization or the code organization. It's not the consistency of or the style, and it's not even the individual file's readability. It's kind of more the macro point of what is the code that we choose to write, and how does that work together? And I think this is actually the real source of complexity. It's not any individual piece, it's how they all fit together. So I'm Alex Tucker. I'm a staff engineer at Wave. I've been at Wave for about 5 years. You can find me on the Twitters if you can read that at the bottom. I've had a very fortunate experience over the last few years at Wave where we've actually rewritten the largest application at Wave. And going into that rewrite, it was already a very complex application. And the reason why we had to rewrite it was that it had so much complexity, we basically incurred so much debt that we couldn't move forward on it. So when we go to rewrite it, we wanted to choose tactics to decrease the complexity as we added more features, and this is the result of years of us working on that together. So I think software design is really hard. I think most of the time there's no good heuristic for knowing if we're on track. Things always start off great and simple. We have greenfield projects. We're going to try this new architecture, this new pattern. But we never get to really test them out at scale, and by the time that happens, it's usually too late. And there's also way too much choice in the industry. I mean, there's so many patterns, so many ideas. What we do is very abstract, very artistic. We can choose to do many, many things, and usually there's kind of this paralysis of choice, and we just go with whatever everyone else is doing, which might not actually work, and probably doesn't work. So I want to kind of break my talk into two sections. One is oriented at the person who might be a beginner or an intermediate, someone who maybe hasn't started their own project, like led a team on a project before. And the other part is going to be more targeted at people who are advanced. Maybe you've led a team, led a project, it has gone wrong before. And maybe you can take away some of these lessons and probably, hopefully stop that complexity from growing in the future. So who here has like taken a course in like object-oriented design in Java, or read a book or read a Medium article? And how do them start with the like ridiculous notion that, you know, you can model a car in objects, right? And it's like you got the car interface. You can drive it. It can turn left. It can turn right. You can inherit a truck from a car, right? And there was this dream that object-oriented was going to be, you can combine data and behavior, and you can model the world like the real world. It turns out modeling the real world is really, really, really damn hard. And most of us don't have the time to do it correctly. At the same time, normally when you're trying to get started and you just finished that introductory course, you go and read something like the Gang of Four Design Patterns book, or you go and read a bunch of cool blog articles about how to architect your code. Or maybe you, just your framework or the tools that you're using have opinions about how you might write extensions. I think there's a lot of really, really bad patterns that actually are not really good for beginners, but seem really cool to use them. A particular pattern I'm going to call out right now is the observer pattern. I think it decouples code way too much and leads to weird hidden side effects, race conditions, all sorts of stuff down the road. And the fact that so many of us have picked that pattern up is outrageous. For anyone who's led a project before, this graph might mean something to you. It's at kind of down at 0, 0. You got a greenfield project. Everything's going great. As I'm adding new features, I'm kind of adding to the complexity. And it's kind of this like frog in boiling water problem, which is you don't feel the incidental complexity growing. And eventually you just say, man, it's getting harder and harder to add things. And as you kind of go up that curve, you label your project as legacy. Maybe you start asking your manager, can we rewrite part of it? Or even worse, can we solve our complexity with microservices? You know, I would love to trade my incidental complexity for distributed systems problems. That's what we want. I've led projects like this when I was a new leader, and I always felt bad about it. But when I went off to start this giant rewrite project of a core system at Wave, I had an idea, which was, could there be a graph where we added intentional complexity to our project? And that would actually kind of stem the ridiculous growth of incidental complexity later on. So with that idea in mind, I'm going to focus on two things. One is simple patterns that you can use to write reliable software. And that's going to be targeted at the junior intermediate person. And then how you can add more constraints to your systems that will actually lead to more reliable code, more targeted at the advanced users. Okay, so there's no more like you can build a car in objects thing. Let's decouple data from behavior, and let's name those. So we can have value objects, so they're just objects that just contain data, and kind of service objects, those only contain the behavior. On the service object side, this isn't like new. I find that most communities have kind of gravitated towards this. Most people kind of get this icky feeling when they write like code in a view. So it's like, I don't want it in a view somewhere, so you go and create a util file or something called services or something like that. And you do this for the sake of testing and reusability. It's great. This is also an observation that Gary Bernhardt made a few years ago in a great talk, and he labeled this pattern FOO, is that you're using objects, but they're not object-oriented. You're not trying to make a car. And I have a secret for you. The Java community did this 20 years ago. This is called an EJB, an Enterprise Java Bean. They just went way too far with it, but if you simplify it down, it actually is pretty useful. So, oh my God, you can't read that. Okay. Value objects, they're just data, no behavior. They're really useful for kind of validation, packaging up data, and building comparators. And they actually simplify the service interfaces, which I'll get to in a minute. They should not be, that's what that red thing says not. They should not be ORM objects. ORM objects encapsulate way too much information. You can persist with them. They got way too much behavior attached to them. And in a world where we're trying to separate our concerns, you're saying that the way I persist my data has to be the way that I'm going to use it in my application, which may be true on day 1, but is definitely not going to be true on day 100. You could use dictionaries. They're convenient. They're just literally bags of data, but you probably shouldn't. They're memory inefficient, and they're actually really hard to work with when you're doing kind of large-scale refactors. If you kind of had concrete objects, which I'll get to an example in a minute, it'll make your life a lot easier. So how would you write a value object? There's a lot of different ways you could do it. You could roll your own kind of plain Python object, write an interface with or write a constructor with some keyword arguments and some default values, perhaps. You could use the great adders package that's available in Python 2.7 and 3. This is an example using the new name tuple syntax that's available in Python 3.6. Name tuples have been a cool feature, but with the worst interface ever. And now with the optional type hinting stuff, you can actually define name tuples like this. At runtime, they don't do actual type checking, so don't rely on that for validation. The adders package will do that for you. But allows you to really quickly and easily model the values in your system. And you can do cool relationship stuff like that, like the blog author is actually a user and stuff like that. Service objects are the opposite. They're stateless, they contain no data, and they are just the behavior of your system. It's also the place where you're going to be modeling the separation of concerns. Services go by a lot of names. Some people call them services, some people call them containers, some people call them components. I think as an industry, we should try standardizing what this pattern is actually called. And here's an example of what a service object could look like. It's just a plain object with a stateless function on it. It takes in a blog value object. Instead of all the different properties of a blog value object, you can just pass in a blog. It does some work. It then uses the ORM and then returns a blog. Here's an example at the bottom of actually using it. You might put that code in your view or your task. And one thing to point out here is that, I think this is best practice in a lot of people's minds, but don't leak ORM objects out of this interface. If you have value objects, you want to operate on value objects everywhere. This is actually where you lock away your ORM stuff or anything that does I/O. Okay, quick little break. If I haven't said a lot of names or things that have been ambiguous so far, it's about to get a lot worse. And I'm going to try to do my best to add meaning to them in the face of we have no actual convention for these things. So separation of concerns is something that you are going to use to choose what code goes where. And you can kind of break this into two different main ideas. One is the domain. So here's an example of if I want to send an email, there's actually a bunch of different things that are involved in sending an email. I need to get the data to send to that's going to be in the email. I need to generate the HTML that's going to be the email, and then I need to send the email. So that's one way you could actually break down an email into three separate kind of domain-specific parts. Now I could write code that's just, it's not one like giant God object that does all those things. It's broken down into those three distinct parts. Separation of concerns could also mean kind of system-level problems like I/O, things like talking to a database, making an API call, opening a file. All these things are traditionally hard to unit test. Other kind of layers in there are logic, coordination, and workflow, which we'll go on to later. So if I wanted to separate out my services by system concerns, if I took that example before, I would have one what I would call the blog publish service, where it has the logic, and maybe something called a blog publish backend that actually persists it using the ORM. Now, if you took this example and just as it is, it's saying that I have to call both of these in my actual application, like view code or something like that. It actually seems really inconvenient for a developer. So we could actually use something that it's also not very popular in the Python world, which is dependency injection. So in the initializer for the blog publish service, I'm going to take in, you can pass in a blog publish backend or any mock of it. If you don't pass in anything, this one just does some default construction for you. And then in the publish blog, I call the backend's publish blog to actually go and persist it for me using the ORM. And now I get the same example that we had in the beginning, is that in my view code, I get the same interface. But I got that kind of layers separation of concerns going on. So I've said layers a bunch of times without any context. And layers are just the different things that you choose to separate your system concerns. And you can kind of visualize them like this, is that I want everything that has to do with logic in one layer, everything that has to do with I/O in another layer. All those I/O level things get injected into the service levels, and then all my view code, my tasks, all my framework code, those things only operate on the service level things. That blue line represents a seam that is traditionally hard to test over. If you ever end up writing integration tests or end-to-end tests, It's a real pain when you have to like mock out a HTTP call or something like that. Then, if you use this pattern, you can actually completely replace that implementation with a fake at runtime. Another thing is that you get to decide what different things are going to go in different layers. So you can make a call like all of my validation is going to go in the backends layer. Or you can say all of my serialization is going to happen in the service layer. You can even do some interesting things like say, I'm going to open all of my database transactions in the surface layer or some other layer. Okay. If that was a little over your head, that's okay, but I'm going to go a little bit deeper on some other ideas. If you're a beginner, if you're looking for something simpler to write your code, use those patterns. But if you wanted to write some non-trivial applications, you might want to take in some other considerations. So we all say inheritance is bad, and everyone says we should do composition instead. What is composition? Can anyone describe it? No? Mark?
Well, you're combining various objects to form one. So you have behavior of object A and B, and you create a new object combining the functionality of both.
Yeah, so the idea is that I want some sort of convenience of calling these many parts. And the way I've seen a lot of, here's an example of where it's really inconvenient, is that I have some view, I have all these services, and I have to call them each individually. It's super verbose in my view. And when's if I want to be able to reuse this chunk of code in another view? When's if these are logically grouped together and I never want them to be called in any other way? Well, you can actually visualize it in your mind like this, which is your view is calling out to each of those services are calling out in the back end, and you get this really nice graph. But if I wanted to add some more convenience and I wanted to put less code in my view, well, I could create a blog service that goes and calls all these things for me. There's a problem with that, which is conceptually, you now have this God service that's supposed to have all these ideas around separation of concerns, now calling out to other services and adding its own incidental complexity to my system. And I would say that you're kind of losing this sense of narrative, the idea that there's a contract between the caller and the callee, and I can't pick up any individual service now, and it's going to have a very simple interface on the inside. I might not know in the future someone you onboard in your team tomorrow or you in 3 weeks when you forget that blog service makes 15 different service calls inside of it, that it has all sorts of crazy side effects. So what can you do? Well, you can just keep adding more layers. I mean, layers are a way of intentionally adding complexity to your system to get away from from having incidental complexity creep up on you. I think this is really unnatural for a lot of people to think about adding more layers to their system, but in my experience, it's actually been super, super helpful. In my opinion, this is actually like the crown jewel of composition, is that there's a layer now whose job is just the composition of all my very separated out pieces. And it also allows for reuse. So if I have two views that want to have that same chunk of code run all the time, it's quite easy. So to wrap up, use value objects, use service objects. They're going to simplify your life. And you should be adding intentional complexity to your project so you don't get bitten by incidental complexity. Cool? Any questions?
So I could see the lasagna in there. Anyone with questions? Yes.
Do you know of any publicly available projects that implement this sort of pattern that we could have a look at? Or anything like that?
Not off the top of my head. And in terms of like frameworks for implementing this stuff, I would also suggest not using them. To write the framework for this stuff is 50 lines of code, and you should just own that yourself.
What are some tools that you have at the sort of like project scoping phase for like justifying this? Like the idea of adding complexity, like sort of front loading it. Did you find maybe that was a difficult sell, and maybe some tactics around that?
I think the sell is more on the developer side, is that it's not conventional, and that's really what you just have to challenge people on. Very quickly, people realize the value of it. I think that's really the only challenge.
Hi. You mentioned the orchestration layer. Could you mention some more details around it and how it simplifies services?
Right. So the orchestration layer is intended to only call services. It has no logic or anything in it, but it does wrap up multiple service calls into one chunk that you can then call from your Vue code.
So you started off talking about how this was sort of born out of a rewrite. Could you maybe offer some insight into how we might adapt our own legacy applications using this pattern without necessarily rewrite? Or you just comment on that.
So if you already have some sort of separation of concerns, kind of like you already have this service pattern, you're kind of already on track. I would say that you can incrementally add kind of those orchestration layers as you write new code or refactor existing code. It can be added very incrementally to any project, in my opinion. Yes, you'll be in a period of inconsistency in your code base, but I think that'll actually just motivate you to get through it.
Any other question? Right here.
Would you call this an interface to services, your orchestration layer?
Yes. Oh God.
You mentioned Java.
Yes. Such Java.
I have a question sort of on performance implications. So, for example, we're trying to do a lot of cohesive design, and with sort of separation concern in mind, how will you deal with like high performance applications where you kind of need to know a bit more details on the lower level implementations?
So I don't have any hard evidence on the performance implications. I will call out though that you should make all of your everything in these layers should be singletons. They should be evoked and stood up when your application starts and not continually rebuilt on every request. We did that once and it was really, really bad. So we don't see, we have a many layered application and we don't see any performance problems because it's all stood up when the application starts.
Maybe this is a dumb question, but can something in one layer only talk one layer up or one layer down, or can they skip layers?
Okay, I love you. I actually missed to say something. So through this pattern, you should have a rule that you say things in the same layer can't talk to other things in the same layer. And I'd say that it's okay to skip a layer going down, and there's practical reasons to do that. But as long as you don't talk to other things in the same layer, you avoid the complexity, you avoid possible loops or weird race conditions as well.
Okay, I get to walk all the way back again.
Can you talk to your layer above you?
No. You only pass back to it. So you want it to coordinate you.
Yep, all the way back to the front. We could organize like a lasagna, and I could go by
Yeah,
layers, and can go up again.
Hi. If you're introducing more fairly complex views, do you create an entirely new orchestration layer encapsulating the logic behind that, or is there only one monolithic orchestration layer?
So it would be okay to call multiple orchestrators in a view. It's not that you can only have one call into it. It just, I would say you should naturally let it evolve. So if you have a view that you want to do a lot of stuff, maybe it's some sort of admin view or something. It's okay if it calls out to 5 different orchestration layers and that fans out to all sorts of services under the hood. But if that's a pattern that you want to repeat somewhere else, you could either think about rewriting something new in your orchestration layer, or you can add a new layer.
Great, thank you.
One more, 2 more.
Have you ever run into a case where you kind of ended up adding a layer and it didn't end up panning out as well as you thought and ended up being a little bit too blurry?
So adding layers should be very, very intentional. And I would probably not lightly add new layers. You should try to stretch what can be defined in a layer as far as you can until there's a real need to add it. So I personally haven't been in that case yet. But being able to skip a layer is something that's powerful as well, because sometimes not all your code requires that level of complexity.
Hi, thank you for the talk. I have 2 comments. First is, I have been using this kind of pattern and it's really, really, really good. And the second thing is, there was a question saying, can someone point to some code base which does something like this? Some of the recent machine learning toolkits are encouraging a kind of art design that the user has to go in this layer kind of thing. And not just to make the network, but to have this end-to-end execution of it. So it's really, really useful and powerful paradigm. Thank you.
Great, thank you.
Quick one. It's a yes or no question, okay?
Could you recommend any resources for people that want to know more in lieu of the traditional programming structure books?
Go and watch Gary Bernhardt's talk. I forget which one it is. Just search Gary Bernhardt FOO, and does a much better job of explaining kind of the kernel of this idea. But or watch this talk again.
So thank you so much, Alex, for your non-lasagna. And now we have all a craving for pasta.